Alright, so this session we're going to be talking about CloudFormation. I'll start with Amazon's little blurb on why we should use CloudFormation, and then we'll kind of get into it.
When you're managing infrastructure, maybe you're using runbooks and scripts to create and manage everything. Version controlling and keeping track of changes can be challenging. And things get even harder when you need to replicate your entire production stack multiple times for development and testing purposes. But provisioning an infrastructure stack directly from a collection of scripts isn't simple. Wouldn't it be great if you could create and manage your infrastructure and application stack in a controlled and predictable way? Introducing AWS CloudFormation. CloudFormation provisions and manages stacks of AWS resources based on templates you create to model your infrastructure architecture. You can manage anything, from a single Amazon EC2 instance to a complex multi-tier, multi-region application. CloudFormation can be used to define simple things like an Amazon VPC subnet, as well as provisioning services such as AWS OpsWorks or AWS Elastic Beanstalk. It's easy to get started with CloudFormation. You simply create a template, which is a JSON file that serves as a blueprint to define the configuration of all the AWS resources that make up your infrastructure and application stack. Or you can select a sample pre-built template that CloudFormation provides for commonly used architectures, such as a LAMP stack running on Amazon EC2 and Amazon RDS. Next, you just upload your template to CloudFormation. You can also select parameters, such as the number of instances or instance type if necessary. Then, CloudFormation will provision and configure your AWS resource stack. You can update your CloudFormation stack at any time by uploading a modified template through the AWS Management Console, command line, or SDK. You can also check your template into version control so you're able to keep track of all changes made to your infrastructure and application stack. With CloudFormation, you can version control your infrastructure architecture the same way you would with software code. Provisioning infrastructure is as simple as creating and uploading a template to CloudFormation. This makes replicating your infrastructure very simple. You can easily and quickly spin up a replica of your production stack for development and testing with a few clicks in the AWS Management Console. You can tear down and rebuild the replica stacks whenever you want. Replicating a production stack could have been time-consuming and error-prone if you did it manually. But with CloudFormation, you can create and manage AWS resource stacks quickly and reliably. And there's no additional charge for CloudFormation. You only pay for the AWS resources that CloudFormation creates and your application uses. To get started, visit our website and launch your first stack with AWS CloudFormation today.
Yep. So what CloudFormation allows you to do is you can create a template for all the resources you need and how they will be organized together. The benefit of that is if you had to do it all manually every time and something changed, like you wanted to change it in some way, or you have to reconfigure it somewhere else, then you'd have to manually go through the exact same steps. If you don't, it would likely fail. Also, because you can provision what security measures and what permissions there are within CloudFormation instead of manually, you can make sure the resources are better secured because you don't accidentally mess something up. CloudFormation is the better way to do everything we've been doing. If we were doing it correctly, we would first do it in the console just to get a feel for it, and then we do the same thing in CloudFormation so that we can just, within a single click, make it the same way every time. So let's look at what we have right now in SQS. Right now in SQS, we have the crawler that we made last time. So what we're going to do is I'm going to show you a very small template for making a queue with the exact same specifications. And then we're going to add on to that the templating to actually make the Dynamo table, which will be more complicated. But if we look at this right here, this is the CloudFormation that will make the queue. The format version, this is what version of the API. This is the most up-to-date. Description, just kind of saying what you're doing. These are the resources it's creating. It's creating only one, a queue, gave it the name crawler queue2. And then outputs. With outputs, you can actually reference these with other CloudFormation documents. So if we're going to do the entire process we've been doing, what we could do is we could, within CloudFormation, create the Lambda function, and then automatically link in the queue name and the ARN into the Lambda function, instead of having to manually go in and link those two together. That way, as soon as we run CloudFormation, everything's up and running immediately. So now let's actually run this CloudFormation. Here, we'll create a new stack, and then I'll just select the file I made, caller.yaml, and then next. Stack name, I'll name it crawler2. I don't need to give it any tags, options, or anything. Rollback timing and triggers. What these are is, oftentimes with CloudFormation, you'll be using it when you're going to build a very complex system, like a system with multiple resource dependencies that could very easily fail. So what this does is you can set a certain amount of time, this is in minutes here, that says if you've been trying to make this for, let's just say, 10 minutes, and you can't do it, that means there's some sort of deadlock happening, and I just want you to undo everything and fail. The biggest benefit to CloudFormation is updating and rollback. So you could write like a bash script, because all this is doing is all commands you can do within like a bash script or with the Python Boto 3. The additional benefit they give you is if something fails, they will undo all of their changes and go back to the last working version, which is something that would be a lot of code for you to implement yourself if you're going to do it in Boto 3 or the CLI. With the alarm, you can specify if some alarm fails, then the whole thing will roll back. We don't need to worry about any of that, though. Alright, and then we'll create it. Now it's creating. It'll give you a log of all the events that are happening as it's going through. Fresh. And it's done. Didn't have that much to do. First thing it did is it said, alright, I'm a stack, getting the information I need. It started to create the queue. And then it finished creating the queue, and then the stack was done. If we look at the resources right here, we created our queue right here. And these are the outputs that we specified. The crawler queue URL with referencing this crawler queue, and right here, and then the ARN, crawler queue ARN, which gets the ARN attribute from the crawler queue. And we'll go into this probably more depth next semester. This will be like one of the last sessions we have for this semester. But there are some companies doing very advanced stuff with CloudFormation. We're only going to barely scratch the surface, though. Alright, and so now if we go look at SQS, now we have crawler Q2, the queue we made. And this crawler Q2 has the exact same specifications as the crawler queue we made ourselves. That's because if we look here, this is the CloudFormation queue. With their CloudFormation stuff, they have very good documentation. which we'll go through when we make the dynamo table. But they tell you what's required and then what the default is. See, most of the stuff isn't required, and we use the default settings for most of the queue stuff. So the only thing that we had to put was the name. We don't even have to put the name. They would just make up an ugly name for us, so it's better if we make one. Alright, so now let's work on creating a dynamo table here too. So first thing we're going to do is crawl our table. This will be the name of how we identify the resource within CloudFormation is with this name. Its type, we can go here, AWS DynamoDB table. And then we put in all the properties here. You can either do it in JSON or YAML. I tend to use YAML just because it's easier for me to read. The benefit of JSON is white space doesn't matter, so it's easier to like copy and paste and like move it around like that. You can think of it, JSON is JavaScript. It's JavaScript object notation. That's what it's for. And then Python and YAML is like associated with Python, so white space matters. So go here. Let's go through the properties one by one. Alright, first off, attribute definitions. This is a required attribute, so we know we're going to have this one. So let's first off put in properties and put on and for you guys following along, do you want me to stop for a minute so you can copy what we have here? Yeah. And then I just named this file crawler.yaml. Yeah, and white space matters here, so these aren't tabbed at all. This is one tab right here, another tab, one tab, another tab, third tab for the list. Another thing you can specify in CloudFormation that we're not going to do for this one is you can specify parameters. Those would be basically variables that when you run the CloudFormation, you'd specify at runtime. That way you can do stuff like run CloudFormation and give it like a number of instances to make, and they'll make that number. Or if you want to specify the name at runtime, if you want this to be purely agnostic on that front. And then, yeah, a bunch of other options. One thing that I've done before is you can have it so that whenever you rerun, you use the same number of instances that you previously provisioned. Like if you have to manually increase the number, it'll have that increase automatically when you rerun CloudFormation. And then you just have an additional script, and all that script does is take in the number of instances running, and then supplies that as a parameter when it runs CloudFormation. Because you can run CloudFormation as an AWS CLI command. And I want everyone to ignore this part. Like, you can leave this part out for now, but I want everyone to run it themselves. So run this right here to make sure you have it working for you. And then let me know where you guys are at with that so I can make sure to help you with that part. So are you able to run it?
Some typo.
Yeah. Oh, you mixed up the W and the S.
Oh, okay. I see. Should be good. So running it as a sign on your
For this, just choose file. Here, you go back to your. Here, you have this all tabbed additional.
Oh,
So delete that tab. Yeah, untab it. Yeah, there we go. Oh, yep, the W and S need to be capitalized. Yeah, he'll be very picky with all this needing to be exact.
Yep.
Nice.
So
Just whatever, just as long as it doesn't conflict with any steps you have. At this point is 0, so it can be anything. You don't need to worry about any of that.
create a stack.
Perfect.
So why do they have like views thing? Just
This?
Yeah.
Oh, this is saying, this is everything it's doing. Will like update you the status. Click refresh right there.
all right.
Click refresh. All right, you're good. And then you can look in SQS and see your queue.
So this basically help us to create like everything
Yep. With this, you can create all your resources.
and everything and all of them are in one stack.
Yep, and you can.
So for one project.
Oh, sometimes you'll spread it across multiple stacks,
Okay.
and then you can coordinate the stacks.
Okay.
Like one stack is dependent on another, and you can have it so the outputs of one stack, the other stack reads those in, or
Okay.
inputs on what they do.
Alright.
Yeah, you can do some pretty complex stuff. Yeah. So if you go to SQS,
This is another.
yep, that's the key command. Perfect. Yep. All right. YouTube. Go here. Line 5. Oh, it's supposed to work with tabs, right? Yeah. Spaces after the cold. Yeah, and if you guys are having trouble, JSON will probably work better. I just think this looks nicer.
Yeah. Readable.
It's complaining about this here. So line 7, column 1. You say there's supposed to be spaces after the colon?
There are, not the ones I entered though. Like they don't have.
This one needs space.
Try it. It shouldn't matter. Is it something funky with your view line characters? Or your tabs or the spaces? So it could be.
So last time I used the AWS mobile.
The AWS what?
Mobile.
Mobile?
Something like that create like the whole backend system for a mobile app.
Oh, for like a template? Like
No, just like a backend stuff, like a dynamo table and maybe SQS. I don't know. It was pretty good. Yeah. I mean the time we missed, I didn't come to this session.
Oh
We
yeah.
went to a hackathon
Oh
in the
nice.
downtown.
Nice.
And then we used the stuff, and because we have no enough experience and took too much time for us to create a backend and build a project.
Yeah. Actually, we were talking about this. The next big project for next semester will be creating an app
Oh,
for the backend stuff.
That's very cool. Even the login system is included, like a Facebook login.
Yeah.
It's very cool. I don't even know how it's works. I just follow the step.
Yeah.
The login system is done.
Yeah. Here, and if you guys are having trouble, you can go to the JSON, do the JSON version. I'll put it right here. It'll be pretty similar, except white space won't matter.
I'm going back to JSON because I was
So yeah, it'll be the same thing, except everything will be quoted. And then whenever there were tabs, you'll be putting like brackets and then commas after everything. And then you actually don't need to worry about outputs, so we can ignore that for this part. So this JSON should work as well. And in a lot of ways, JSON works better just because white space issues, especially with like file sharing and working on it with other people. Again, to my previous point, it just looks uglier. Yeah. Oh, sounds good.
I forgot about this.
Oh,
starting bracket.
the first bracket.
Hmm?
The first bracket. Yeah.
Also, I was trying to use the notepad initially, and apparently it says everything's a text file, even if you put a .yaml or suffix. Yeah. It's like weird. So I had to do Notepad++. Because Windows is fun.
You change your computer?
Oh yeah, my old one broke.
Oh, why?
I'm not sure. Not sure exactly how, and they claim it's water damages. I never spilled any.
Okay, I see.
So I don't know. And now I have new ones. So. Wait, that's
Hope not saying.
Is it a gaming one?
Yeah.
Yeah, I see that. Design.
yeah, but
It's a very gaming design.
it's quite large. Yeah, it's weird. You have the right number of. I don't know if all the laptops have this now, but.
All the gaming I don't have. I think it's for the fan.
Yeah, it's definitely for the fan. Because my old laptop would just shoot it downwards, and so it'd go into my lap, and that wouldn't really cool much.
Oh,
But now it's like even if I put it on my lap, it just flows outwards, so it's not a problem. It's also very loud.
yeah.
It's like I'm like, okay, I'm sorry. Sorry for eating something.
But you don't, as long as you don't play games, it's fine. Right?
Yeah.
What's the graphic card?
Yeah, it's got NVIDIA like 1060 maybe.
Oh, it's pretty good.
Yeah.
And then you could just
Can run.
just those to be unique within the stacks you have.
You can run
This
most
is
of
your
it.
own stack. So
Yeah.
whatever you choose.
I haven't seen something that can't run at least on lower settings.
Okay.
So.
And then you pick something else. Alright, perfect. So, for these next parts, I'll be doing them in the YAML stuff to test it, but it'll be the same sort of syntax here. You would just, this is for properties, this is for properties, for type, this is for, okay, so just comma, and then your other resource here, which would be the table. Crawler table. Then yada yada yada. Alright. So next we'll create the table. So call it crawler table here. The type is AWS DynamoDB. Is it table? Yeah, it's table. Yes. And then we'll have properties to define. At this point, we don't know what properties we have to define or not. We'll go through and look at them all to see what we need to do, and then we can flush those out. So, yeah, give me the thumbs up when you guys are ready. Nice. Alright, so let's go look at what properties we need. One thing, alright, so list it as required. So we're going to need attribute definitions. Attribute definitions are going to define the schema for our database. So let's put in, for this property, we have attribute definitions. And then one thing that's good is at the bottom, they give you an example. Attribute definitions are going to be a list of each attribute name and then attribute type. S denotes a string, N denotes a number. Sure, there are other ones. We're only really going to need to be working with S though, because we have 1, our unique identifier, and 2, our base URL. So for here, attribute definitions, and see, this is the JSON version. So if you guys want to pull up the docs for the JSON and the YAML, it'll be really helpful for like how you're going to write it. To find this, I just Google CloudFormation DynamoDB, and then it's the first link. Yep. So for JSON, it looks like this. It has the bracket after the colon, and then, yeah, the square bracket after the colon, and then all of this afterward, each attribute. For YAML, the lists have these dashes in front of them. I don't know why they're spaced so weird here, but we'll do it a better looking way. Attribute definitions, attribute name, yep, attribute name, and then the first name, let's call it ID for the identifier. And then attribute type, this will be a string. And then we'll have another one, attribute name, and this one will be base URL, attribute type, and this one will also be a string. So this is a way we can define the schema for our database. If we look back here, and then after we flush this all out, I'll give you guys time to like copy it all down, anything that you've like missed. Alright, and then here is also something really important that they mention. It says update requires some interruptions. So basically, some updates to your resources, you can have them do and have no downtime whatsoever. That is not the case when you're updating the schema for your database. Not necessarily. It may interrupt some stuff. So that's something that's nice to be aware of. Not really at our level, but if you're thinking at like a higher level, if you have like a resource that a lot of people are depending on, be aware that there'll be possibly a couple minutes outage. Next is global secondary indexes. We don't need that, and it's not required, so we can skip over that one. Key schema, this is required. So the key schema is, this will be what the primary key is. So basically, how we will identify it, each entry as unique. That's what we're using our ID for a unique specifier. So if we look down here for key schema example, and here, this will be better for this part. An update requires replacement. We'll need to replace the whole database. So the options are hash or range. For databases, you use a range when you're going to be doing generally something called B+ search, where you can try to find the value by, and you usually use it for some integer. So let's say your unique identifier is the number 5. If you make it a range, then you can find everything with the identifier between like 5 and 9 very easily. Well, hash is good for finding a single value. And so since we're using strings, like unique IDs, we're going to be using hash because ranges of these unique IDs would be irrelevant because they'll be just randomly placed all around. So we'll go back here. It's really good. For key schema, it says it is a list of this. So this is what one key schema is. It's a list. We only have one key, so it'll be a list of one item. Let's go here, type in key schema. Right. Yep, and then a list of one item that contains attribute name, ID, and then key type hash.
Be capitalized.
Yep, you're right. All caps. Hash. Okay, nice. Then local segment indexes, not required and we don't need it. Provision throughput. This is the read and write capacity units. Just to refresh your memory, the one read capacity unit means you're allowed to read one thing from the database every minute. Like within a 1 minute period, you can read one thing. The default is 5. We can make this 1. We're not actually going to read or write to the database. So all it is this right here. So we will go to provision throughput. Provisioned throughput. And then we'll have read capacity units 1, write capacity units 1. Okay. We don't need any encryption. It's not required either. Don't need to specify streaming. Table name is not required. It'll give us one, but we want one. We don't want their ugly gibberish to be the name of this table. We want to actually be able to know what it is. And the type right here is string. So go to table name and just make it crawler table 2. Kind of similar to how we named the queue. We don't have any tags. We didn't specify TTL with the last one either. And then here's something really good they have also within the docs is what the different return values are. What we want for this would be the ARN. So let's do that after. Let's first make sure that we have this working, and then we'll go on to getting the outputs. So we have this. Now let's run it and see if there are any typos. Yes. Tried and true method. First thing I'm going to do is I'm going to delete the stack that we made prior. So, yeah. And then when you delete the stack, it will delete all the resources that stack created. One caveat with CloudFormation that's important to note is when you make something with CloudFormation and then manually update aspects of the infrastructure later, and then you try to go back to CloudFormation again, oftentimes there'll be a whole bunch of errors. that are very difficult to sift through and will involve you deleting things manually, which kind of ruins a lot of the benefits of CloudFormation in that situation. So just something to be aware of. If you're going to be manipulating resources after the fact, try to do it also within CloudFormation. Alright, still deleting. Here we go. Alright, now it's fully deleted. I'll create a new stack. Use this. Alright, it's good. I'll name it crawler 2 again. There's no more crawler 2 anymore. Yep. Create failed. Let's see. Property attribute definitions is inconsistent with key schema of the table and secondary indexes. Alright. So let's try to see what this is about. We can look at the template here. Okay. So we go here. Wonder. See what the issue was. I don't think that would be it, but give it a go. It said, what did it say? And see, this is one good thing about it, is it rolled back the creation of the queue when the table failed. So it's like if any aspect of it fails, it gets rid of everything it does. Alright. So look, property attribute definitions can keep it on the table and secondary. Property attribute definitions. Alright. So there's something wrong with how we specified attribute definitions and key schema together.
Do you want the quotation?
Maybe.
With the hash also?
Oh, yeah, you're right. They do want quote. I don't know if that would matter, but we can give her a go. Property attribute definitions is consistent with the key schema of the table and secondary indexes.
Do we need to define global secondary indexes?
Maybe. Let's use the handy dandy internet for this one.
that should be defined here are those that will be used as keys.
Yeah, I see that too. So if we delete this, would it be good? Let's try it.
There were the comments in JSON.
I assume it's just Python commenting, since that's how it's parsed. Yeah, it's looking like that's it. Nice. So I wonder, does the schema not have to be fully specified, but will automatically do it if you put in entries to the database with those values? I'm thinking that might be it, but we can run a test just to be sure. Boom, create complete. Nice. So if we then go to our table right here, call our table 2. Alright, it's just ID, but let's try adding an element. Yeah, so we can add an additional field. Yep. So we only need to specify. That's why, and that's what I was getting confused on. I thought we had to specify the full schema right here. But because how DynamoDB parses it is it parses it through JSON right here, because this is a NoSQL database, you can just arbitrarily add different elements to items you put in, and then there'll be an entry in the table. It'll show up as an entry in the table. So, Sam, you're exactly right. We just needed to do things we're using as either the primary key or like secondary indexes.
So like things we have to sort by.
Yep, exactly. And so, yeah, do you guys have, are you guys also able to run this?
I still have error in my
Alright, let's take a look.
Yeah, they're back.
Here, so for you guys that are done, I want you to add in, based off of this, I want you to add into the output getting the ARN. It'll work pretty much the same way as you get the ARN for the queue and like these outputs right here. But I want you to add that in for the table.
So line 7. Because we have any properties, I think. Just like this. You have opened the. So yeah, this, that, all that. Okay, what's the errors there? This is the errors
say in the console. Yeah. JSON. Just JSON. Oh, maybe is that trailing comma? I don't think we should care about the trailing comma. Oh, all right, perfect.
Alright, have you guys been able to get the... Yep. So do it in much the same way. You'll do crawler table arm in the output. Specify the value to be the get attribute function that will take the crawler table and will give us the arm of the crawler table. So then if we go back here, now what I'm doing right here is I'm updating the stack instead of deleting and remaking. Let's take a look on how that will change things. We don't change much of the underlying stuff, just the output. So it shouldn't be much. If you see here right now it says update in progress, and bit out of time, but one thing you could also see is if you put a deliberate error in your CloudFormation and then tried to update it, it'll then just go back to your last working version. So the update just won't go through. Update complete. If we look at outputs, now we have a crawler table arm as an output. So now we could then reference that arm for other stuff, like our Lambda function. Yep, and here's the final bits. Make it all. Yep. Perfect. So next semester, one thing we'll do more is we'll show people how to do stuff within the console, but then we'll also actually start with CloudFormation much earlier, just because it's very important and underlying to a lot of stuff, especially if you want to make a very complicated system. If you're trying to do it without CloudFormation, then you're just fighting an uphill battle that you don't need to be fighting.